All right, welcome to our webinar today. Good morning, good afternoon, wherever you're joining us from. We're happy to have you here. Today's webinar is co-hosted by the New York Oracle User Group and Oracle partner Viscosity North America. We've got a great presenter for you today. He's actually one of my colleagues, and I'm super excited to have him here to talk about Postgres. This is a live webinar, so feel free to submit questions as you want in the Q&A field, and he'll get to your questions as he can, either during his presentation or following afterwards. This webinar is recorded, so you will be able to go back to it and rewatch it. All right. So first, my name is Monica. I'm the marketing director here at Viscosity. I'll tell you a little bit about us, but first I'm going to hand it over to Coleman, Vice President of NYOUG, to tell you a little bit about them.
Thank you, Monica. First slide. Thank you. So, the New York Oracle Users Group was formed in 1984 for the exchange of ideas and assistance and support among users of Oracle software products. Next slide. And you can connect with us at NYOUG underscore NYC on X, formerly known as Twitter, Meetup, LinkedIn, Facebook, and of course our website, which has this webinar be posted there, and other webinars going back to actually from 2020, from May 2020 with co-hosting with Viscosity at nyoug.org. And thank you again, Viscosity, for co-hosting these series of webinars with us.
Thank you, Coleman. We're always so excited to be able to partner with user groups, and this long partnership we've had with NYOUG has been super successful and just honestly so great. All right, so a little bit about Viscosity. We are a full Oracle and Microsoft stack consulting firm. We do have folks like James here who work and present on different databases as well. So that's what you'll hear about today. But I do want to show you a little bit about our services model. We are based on these three main pillars: data, apps, and cloud or infrastructure. Across the bottom, you'll see services that we provide for all three pillars. So if you need any assessments, health checks, even remote managed services, things like that, we do it all, as well as proof of concepts and project work. All right. These are some of the books that our consultants have written. If you're on the Oracle side, they're mostly all Oracle. And then these are some of our recognized speakers. They represent our executive and management staff here at Viscosity. They are regular presenters at conferences nationwide and even globally. All right, and then finally, orapub.com is where you can go to rewatch and view slide decks from all of our webinars, whether they're with NYOUG, from a conference, or from something else. They will be posted here. You do have to be a member, but there is a free membership tier, so feel free to go there and check out our database of stuff. This was created by a former Oracle employee who is now our data scientist and applied scientist here at Viscosity, Craig Shalahammer. So there is some stuff in there that is far older. That was his before he came to Viscosity in 2021. So, or 2022. But yeah, there's a lot of great stuff in there. And since Orapub became part of the Viscosity family, we have filled it up with even more resources. So definitely go check it out. And if you're interested in live virtual training, we have sessions there that you can actually pay for as well and participate in. I did want to show you guys real quick our newest friend here and Viscosity unofficial official employee, Shane AI. He is a chat bot we have that you can use for any of your performance issues. Currently, he is all Oracle. So if you are running any Oracle environments, you can actually go in there and ask Shane anything about your performance issues. And he is actually pulling from all Viscosity resources we have, whether it's publications, blogs, any public Oracle documentations, things like that. great little resource to just like ask a couple questions and see what's up. He's fun because he's also a surfer, so he kind of talks to you in bro mode, which we may have a toggle off button. I think some people are not about bro mode, but we love it. Shane is a cool dude, so go check that out through AuraPub. And with that, I'm going to go ahead and turn it back to Coleman so we can get the show started.
Thank you, Monica. So just a brief introduction about James Vanderpoel. He's a senior principal data content engineer over at Viscosity. And James will tell you more about himself as the webinar starts. And thank you, Viscosity. Thank you, James, for appearing today on Viscosity webinar.
Excellent. Thank you, sir. Okay, I'm going to go ahead and share my screen real quick. Make sure that I am presenting. And you can see that.
Looks great.
Okay, all right. So I'll get to myself in just a second. Today's class is PostgreSQL replication, high availability and load balancing, and log shipping. Just before we get started, a brief introduction of myself. As it's been said, I've served as senior principal consultant for Viscosity North America since August of 2023. I specialize in PostgreSQL as well as SQL Server, Azure Cloud, and all things data related in the Microsoft ecosystem. Prior to my role here at Viscosity, I served as a senior database administrator on DevOps and production teams for a number of companies in industries ranging from finance to energy, going all the way back to 2016. I've got some personal information here, my LinkedIn profile, things of that nature, as well as my email. If you have any questions, don't be shy. Go ahead and send them out, and I will, in addition to the question and answer board, I don't mind answering other mediums. So this is just a quick, brief overview of our agenda today. We're going to talk about what is replication, why you would use it, types of replication available. So that's going to be physical and logical replication, along with synchronous and asynchronous, as well as log shipping. And then we're going to follow up with two lab tutorials. What is replication? Physical or stream replication and logical replication are two methods available within PostgreSQL for replicating data, and they differ in how they copy data and handle changes. Data replication is often used to increase database scalability by distributing the load across a cluster of nodes. Additionally, replication can be used in conjunction with other technologies for high availability and or disaster recovery. The different methods of replication within Postgres are, as I said previously, physical or sometimes called streaming replication. In this case, an entire database is copied binarily by sending complete write-ahead log files to a replica. Write-ahead log files are basically transaction log files. There are two types of physical replication within streaming. There's asynchronous and synchronous. In asynchronous replication, the primary source sends a continuous flow of data to the secondary target. This type of copying has the advantage of speed, but it brings with it a greater risk of data loss between the primary and standby, as data is not acknowledged to have been received before the commit is taken place on the primary. In synchronous replication, the same technology takes place, but there is an added check of a commit taking place after a reporting of data arriving at the standby. So that if the check is successful, the transfer is considered complete, and then a commitment is allowed to be made on both primary and standby. Logical replication is largely different. It replicates data objects and their changes based on their replication identity, which is usually a primary key, but not always. Logical replication uses a publish and subscribe model, where a subscriber pulls data from a publication and applies the changes in the same order as they were applied on the publisher. Sometimes logical replication is referred to as transactional, and it replicates such versus copying an entire database at the binary or file level. So some advantages and disadvantages of physical versus logical replication, just when looking at it overall high view and trying to determine what should we use, or maybe you might use a combination thereof. Physical replication is much faster. However, one replicate all the databases in the cluster. Using a physical replica, it's not possible to replicate a single database belonging to Postgres. Additionally, it's not possible to replicate a subset of tables within any database. Logical replication is slower, but you have the option of choosing what to replicate, whether it's a specific database or subsets of objects within a database. That could be collections of tables within a schema or just specific tables. Physical replication is only possible if the two servers have the same version of PostgreSQL, the same release version, let's say, so 17.17, 16.16. With logical replication, it is possible to form replication between different versions of PostgreSQL, so something to keep in mind. Physical replication also, we said this earlier, it makes an entire identical copy of the primary on the replica server. And so because of that, because the copy is physical at the page level, any bloat that may be present at the primary will also be present at the secondary or standby level. Because the logical replication is actually only replicating the DML statements, and you must execute the DDL on both the primary and secondary. You're not going to see that bloat potentially at the secondary like you would, but that is something you have to manage. Keep in mind too that when you set up a logical replication relationship, you have to execute the data definition language. So any table alterations, table definitions, adding columns, things like that, you have to do so both at the primary and the secondary. So that's additional management that you have to take into account. Types of physical replication in PostgreSQL. This is just going into more detail. We're going to start with the default, which is asynchronous physical replication. This is going to describe it in more detail. Primary server writes changes to a transaction log known as the write-ahead log, and standby servers establish a connection with the primary and continuously read that write-ahead log as it's generated. Changes are then applied to the standby server's databases. Asynchronous replication prioritizes performance and scalability over strict data consistency at every millisecond. Changes are applied on the primary server first and then streamed to the secondary sometime later. That's the key point, sometime later. This allows the primary server to handle transactions simply without waiting for a confirmation from the secondary. And while secondary eventually reflects the changes, there might be a delay, possibly leading to a small window of inconsistency between the primary and these secondaries. And that's something to keep in mind if you're having a situation where you could incur data loss. This trade-off leads to faster overall performance and better scalability, especially for your higher volume databases. And again, we stated that's the default form of streaming replication. So I've got a super high level list of instructions for how to set up an async replication, starting with what you would call the primary or the intended primary. Basically, on the primary server, you have to modify the PostgreSQL conf file. There's a number of configuration file settings that you'll have to set, specifically wall level and max wall senders. Now, both of these are actually within the PostgreSQL conf file. They're just commented out with the pound sign, so you just have to uncomment them. The max wall senders, technically, the requirement is that it be something greater than 1, but its default setting is 10, so I would just leave it at that unless you have additional reasons to make it higher. There is this concept of an additional option called the wall keep segment setting. This PostgreSQL conf setting tells PostgreSQL how many write-ahead log segments to keep on disk. And the default value is 0. So by increasing it to something above 0, you can give yourself a static option to allow the secondary to realign itself should it go down. As long as the secondary comes back up before the primary produces more write-ahead log segments than the integer value of the setting. I actually would not recommend this setting. I'm just including it in here for brevity's sake. There is a second, more dynamic option to create what's called a replication slot within PostgreSQL. Through the slot mechanism, you can tell PostgreSQL to keep the write-ahead log segments until they have been transferred to the replica server. And you would do so simply using a pSQL session or a pgadmin client session. Just running this right here will create that. So we're still talking about additional changes to put on required on the primary. After you've done the said actions, it's a good idea to go ahead and create a role that you would use specifically for replication. We'll just call this replica role here. The additional thing that you'll have to do is alter what's called the PGHBA comp file. And in there, you're going to basically specify a replica role that you created here, as well as the IP address that would be coming from. That's going to be coming from the secondary IP at that point, and this is your setting on the primary. So after making these changes on the config files, you actually have to restart the PostgreSQL cluster or service, and you can do so through either the pgctl utility or systemctl utility if you're using some other flavor of Linux. You'd have to consult that specific documentation, but ultimately you need to restart the process for those values to to be taken into account. Then there are a number of changes required on the secondary server. The first thing is that we're going to actually have to remove and recreate the PG data directory file path as an empty directory and add specific permissions. In order to do that, you actually have to stop the PostgreSQL service on the secondary first. And then in this case, I'm just showing you at the Linux level, at the CLI, how I would remove the main data file and then remake it. And then what I'm doing here is I'm assigning ownership to Postgres and specifically assigning permissions here at chmod 0700. So you have to give these specific permissions for this whole thing to work. From doing that, then you can invoke what's called the pg-base backup utility command from the secondary from inside that main directory file path location. So I give you an example of the syntax used there. We're going to talk about these additional parameters and switches in just a second. So again, pg-base backup, you do a -h, that's for host. You put the primary host IP. Then you'd specify the replica role that we just talked about creating previously, along with the port 5432. And then this data directory here, this is the actual PG data directory that we just recreated with specific permissions. And then the rest of these flags I basically talk about here. The FP performs a backup on the replica, maintaining the same data structure present on the primary. XS basically opens a second connection to the primary server and starts the transfer of the write-ahead log segments at the same time as the backup is performed. There'll be a lab of this showing this in a second if you want to see it in action. P shows the progress of the backup, and then S, this is the slot name created on the primary server, the replication slot that we talked about previously. And R creates a standby signal file and adds the connection settings to the PostgreSQL auto conf file. Starting the PostgreSQL service on the secondary after you run this pg-base backup should start the async replication. So you would simply run something like this using pgctl or systemctl or some other component. But ultimately, starting that PostgreSQL server back up, you should expect to see async replication working at that point. We're just going to cover also synchronous physical replication, which is a very similar setup. There's a few additional settings to put in the conf files. In synchronous replication, the same process replicates data across the secondary. However, when the primary performs a commit, it can only do so after confirmation of replication to all secondaries is reported. Thus, all replicated servers synchronously commit at the same time. Synchronous replication ensures the highest possible security for transactions because a single crashing server can no longer cause data loss. A caveat or warning here: it is good practice to have all identical machines or as close to identical as possible, and of course, a good network connection between those machines. Otherwise, you can have performance degradation with synchronous physical replication. Changes required, again, we're going to go through the same thing, primary and secondary. Required in the primary to set up the synchronous replication is, again, you're going to be on the PostgreSQL conf file, going to be opening it with Vim and uncommenting out the wall level to replica. Then you're also going to uncomment out a synchronous commit to equal on. Previously, this is just commented out. And then you're going to uncomment out the synchronous standby names where you're going to include the names of the standby. Additionally, you'll again have the max wall senders set to 10. And you'll create a role just like you did in the async setup. I use the same role in this example, and then I create the replication slot, just like I did previously. After doing all of this, you also modify, just like in the previous example, the pg-hpa conf file. This is an example of how I would have set it up. After making these adjustments in the config files, you have to restart the cluster on the primary, just as previously done. Then we talked again, cover the changes to be made on the secondary. On the replica server, we have to turn off the PostgreSQL service. Same thing, destroy the PG data directory and remake it as an empty directory with the right permissions. And we now invoke the pg-base backup command from the secondary from inside the previously created PG data directory. So finally, on the standby server, the last caveat is we add a parameter to the connection string. The primary service, the primary knows from whom the reply comes in from the PostgreSQL conf file. So I'm just showing you real quick. This is a snippet of what the PostgreSQL auto conf file would look like. Ironically, it says do not edit this file manually, and that's what I'm asking you to do. But ultimately, there's a section down here where it says application underscore name equals Ubuntu 2. So the Ubuntu 2 is the name of the standby server in this particular case. That's the part that you add. After doing so, go ahead and restart the PostgreSQL instance on the standby, and you should have synchronous replication working. So just a couple additional details about physical replication. There's a concept of cascading replication. So, in many cases, you're going to need multiple asynchronous replicas or copies. And of course, the simplest way to do that is just to hook up a secondary to the primary. However, that causes a lot of load on the primary. So Postgres does have an alternative setup where you can set a standby server to accept replication connections and stream those WAL records that it receives to other standbys, essentially acting as a relay. So this reduces load on the primary, which is of course where your maybe OLTP operations need to be super fast and not burdened by additional reads. You can offload that to a second standby. So just some technical terms to go with that. A standby server acting as both the receiver and the server is referred to as a cascading standby, whereas a normal standby that's just getting its reads directly from the primary is often referred to as an upstream server. Cascading replication is only ever asynchronous. If you are wanting to monitor replication, there is a table or a view available to you called pgstat replication, which you can query from the primary. There is a couple additional options of delayed replication. You can basically set the recovery min apply delay setting in the PostgreSQL comp file to delay replication. It is measured in milliseconds. So by setting it to say 5,000, you're just setting up a 5-second delay. And then of course, if a primary server goes down, you can utilize the pgctl utility to promote the secondary. After doing so, your standby server, which previously would not accept write connections, would then accept write connections, and you could obviously point your application to that should something have happened to your primary. Okay, now we're going to go into logical replication, different from physical replication, which happens at the binary or file level. This form of replication was introduced in version 10. It's often called transactional replication, and it provides more granular control over what can be replicated. With this type of replication, you can replicate individual databases versus the entire instance or cluster, as we say in Postgres, and even subsets of databases, like all objects belonging to a specific schema or just certain tables that you specify and list out explicitly. How it works, logical replication uses a publisher-subscriber model with one or more subscribers subscribing to one or more publications on a publisher node. More on that in a second. Logical replication uses replication identity, usually in the form of a primary key, although it can use a unique key with a specific set of requirements. We'll cover that in just a little while. Logical replication of a table starts with taking a snapshot of the data on the published database, copying that to a subscriber. You do that in the form of a backup and restore, or a PG dump, and then a restore. Once that is done, the changes in the publisher are sent to the subscriber as they occur in real time. The subscriber applies the changes to the data in the same order, so that transaction consistency is guaranteed. And the subscriber database behaves as any other database on the PostgreSQL cluster and can even be used as its own publisher as well. So a publication is a set of changes generated from a table or group of tables and can be defined on any physical replication primary. Oh, can most of the compiled Postgres options be applied? Sorry, I have a question here. Can most of the compiled Postgres config options be applied to a deployed RPM Postgres version in its config files, such as include directory? I believe so. I could probably do a little more research on that and get back to you, but I think that is the case. If you want to give me an email, I can give you more detail on that shortly hereafter. But can a single server host multiple Postgres instances and streaming replicate to another service? So the first question, can a single server host multiple Postgres instances? Yes, the strict limitation is they have to listen on different ports. So the default port is 5432. You would increment up, presumably to 5433, 5435. And of course, your Postgres clusters must have different data directories as well. The second question, and streaming replicate physical standby to another server. I believe that they can, provided that they meet the other additional conditions. I haven't tried that myself, but I believe so. What would be the high-level steps, for example, how to switch instance? Like, or environment, or the right environment in the multi-service on a single server. You know, to be honest with you, to give a competent answer for that, I would have to do a little bit of research and follow up. If there's any chance, Kevin, that you can give your email, I don't mind, you know, giving you a more in-depth answer once I have that information at my fingertips. But I do believe the answer to your question is yes. It's just I would need some time to develop a high-level plan for you. Okay, so each table can be added to multiple publications. Did I start there? Let's see. Let's back up. Server where a publication is defined and is referred to as a publisher. And each publication exists in only one database. That is to say, there is no publication that spans cross databases. Each table can be added to multiple publications and must be added explicitly, except when a publication is created for all tables or for tables in a schema, in which case, you know, specify the schema and it'll do all the tables associated with that schema. Publications can choose. So when do we usually receive the links for the sessions? For example, there's a couple of register for. Oh, that I think Monica would have to answer. Okay, sorry, let me go back to this. Publications can choose to limit changes they produce to any combination of insert, update, delete, and truncate. And by default, all operation types are replicated. Oh, let me go back one real quick. If the table does not have, so this is talking about the primary key or a unique clustered, or I'm sorry, unique index. If the table does not have, let's back up. Publisher table must have what's called a replica identity configured in order to be able to replicate, update, delete operations. By default, this is normally a primary key. However, unique indexes can also be set to the replica identity. If the table does not have any suitable key, it can also be set to what's called replica identity full, which means that the entire row becomes its own key. When the replica identity is set to such, indexes can be used on the subscriber side for searching the rows. Candidate indexes have to be a B tree or hash, non-partial, and the leftmost index field must be a column that references the published table column. It should be noted, though, that replica identity full, in other words, trying to replicate a table without a primary key, this solution should only be used as a fallback if no other solution is possible, as this can cause inefficiencies on the subscriber side. Let's say if you have reporting. So final note, every publication can have multiple subscribers. So moving on to subscription, high level overview, a subscription is a downstream counterpart to publication. Server where a subscription is defined is called a subscriber. A subscribing database behaves in the same way as any other PostgreSQL database and can even be used as a publisher itself. Subscribers can have multiple subscriptions. It's even possible to define multiple subscriptions between a pair, publisher, subscriber. Though extra caution should be exercised to ensure publication objects don't overlap. So there are no built-in guardrails, and you have to make sure and be aware of what you're doing. Each subscription receives changes via one replication slot, and subscriptions can be stopped and resumed at any time and removed as well. When a subscription is dropped and recreated, the synchronization information is lost, schema definitions are not replicated, and the published table must exist on the subscriber. Additional limitations to subscriptions are that only regular tables can be replicated, so you can't replicate things like a view. Procs obviously can't be replicated as well, and replication to differently named tables is also not supported. I do believe that as long as your columns are named the same, they can be in a different order, but they have to be named exactly the same thing, one-to-one, column-to-column. So each subscription receives changes from a replication slot. On the publishing side, these slots are normally created and dropped automatically when the subscription is created and dropped. However, it can be necessary to manipulate the subscription and the underlying slot separately. For example, when creating a subscription and the slot already exists, you can opt for the create slot false option in that create clause. Basic logical replication setup. So this is a very vanilla setup just to give you a high level overview. Changes required on the publisher subscriber. You create a user that will be used in replication just like you did previously. You would alter the PostgreSQL comp file. Some of these settings might look familiar. The wall level. This time, instead of setting it to its default of replica, we're setting it to logical. And then you just comment out the max wall senders to 10 and the max replication slots to 10. After doing this, you would restart the PostgreSQL cluster again. And then you need to actually copy the VDL over to the subscriber, presumably using PG dump. In this example, I pipe PG dump on the secondary over to a PSQL client session. So it creates all the tables as they need, creating a baseline. After that, you create the publication of the publisher, the subscription of the subscriber using similar syntax, which you see here. This is what you created the publisher, and this is what you execute at the subscriber. After such, replication should be working, and you can insert records to the publisher and expect to see them at the subscriber. To monitor logical replication, you can query the pgstat replication table that we previously mentioned with physical replication. Additionally, there'll be a PG publication table at the publisher and a PG subscription table that you can query at the subscriber. In logical replication, writes can technically occur at the subscriber. When these writes conflict or cause problems for logical replication, one quick way to realign your replica server is to just simply drop the subscription at the subscriber, truncate the table, and make the subscription again. Again, this is just a final reminder, DDL commands like the following have to be executed at the publisher and subscriber because DDL is not replicated, only DML statements. So you have that additional overhead of management. There's probably extensions that help manage that, but they're out of scope for this particular webinar. Table partitioning and logical replication. So before PostgreSQL 13, logical replication, so we're just going to mention real quick that before release 13, logical replication of declarative partition tables was not supported. Previously, there was sort of a hack. Previous partitions had to be replicated individually as tables. We'd have to create a separate replication for each underlying child partition. With Postgres 13 and beyond, the partition table can be published explicitly, causing all its partitions to be published automatically. Okay, so Kevin says, my background is, sorry, I'm going to hit a question real quick. My background is primarily Oracle DBA. If I have multi-user defined DBs in a Postgres instance, can I stream replication only certain DBs? Since first, there is no way to stop only certain DBs. If I'm wrong. If not, it's the only option you have is if the Postgres is created with another PG port. Migrate the DB to new instance and then build streaming replication. Can I stream replicate only certain DBs? You cannot stream replicate specific DBs. In other words, you would have to use logical replication for that facility. You could have, I think, multiple instances and stream those instances to separate places, but within streaming replication, it's not an option to specifically replicate just a single database. It's at an instance level or at a cluster level, as we see in Postgres. So with so we talked about this, Postgres 13 and beyond, you can explicitly replicate partition tables. Additionally, on the subscriber side, logical replication supports replicating into partition tables. Prior to this release, subscribers could only receive rows into non-partition tables. Okay. Moving on to logical shipping. Log shipping is what I meant to say. So log shipping, sometimes referred to as warm standby, is basically when you continuously archive to create a high availability solution with one or more standby servers. It's essentially doing backups and restores, restoring databases to a point in time on a secondary server and leaving that in like a recovery state. And those standbys basically are ready to take over operations if something happens to the primary. So log shipping, the primary server operates in continuous archiving mode, while each standby server operates in continuous recovery mode. Reading the write-ahead log files from the primary. No changes to the database tables are required for this to enable this capability, so it offers low administration overhead compared to some other replication solutions that we previously mentioned. This configuration also has relatively low performance impact on the primary server, making it a great candidate. Directly moving write-ahead logs. Records from one database server to another is typically described as log shipping. PostgreSQL implements file-based log shipping by transferring write-ahead log records one file at a time. Write-ahead log files can be shipped easily and cheaply over any distance, whether it be to an adjacent system, another system at the same site, or another system on the other side of the globe. So this is an appropriate solution for HA and DR. Bandwidth required for this technique varies according to the transaction rate of the primary server, and record-based log shipping is more granular and streams write-ahead log changes incrementally over a network connection. Because log shipping is always asynchronous, the write-ahead logs are shipped after the commit on the primary. It is recommended to create primary and standby servers there as close as possible in hardware specs and things like that. Definitely the same PostgreSQL release version. I don't believe that differing versions log shipping is supported. Another example of this needing to be as simple as possible is things like table space path names. Path names switching table spaces will be passed across unmodified. So both primary and standby servers must have the same mount paths. General log shipping between servers running different PostgreSQL release levels is not possible. We did just mention that. Preparing the primary for standby. So at a high level, you set up there's archiving on the primary server to an archive directory accessible from the standby, and that is separate from the primary should the primary go down. So think like a file path or a file share location. If you want to use streaming application to set up authentication on the primary server to application connections from the standby, that is create a role and provide suitable entry or entries in the PG HPA comp file with the database field set to replication, like we previously set. Also, we've talked about this, ensure max wall senders, which is something we've uncommented out in previous slides. It sets a sufficiently large enough number in the configuration file on the primary server. If replication slots will be used, ensure that max replication size is set to a sufficiently high level as well. And then you take a base backup to bootstrap the standby server and you restore over there. Presumably with what we used to call the SQL server, the no recovery. So standby servers, you basically set that up by storing the base backup to the primary and creating a file that we call the standby signal in the standby cluster data directory. You set the restore command to a simple command to copy files from the write ahead log archive. If you plan to have multiple standby servers, which you can, make sure that recovery target timeline is set to the latest, the default, to make the standby server follow the timeline change that occurs at failover to another standby. If you want to use stream replication, you fill in the primary connection info with a libpq connection string, including the host name or IP address, the additional details needed to connect to the primary server. And if the primary server needs password authentication, the password needs to be specified in the primary connection info as well. If you are setting up the standby server for high availability purposes, set up the write ahead log archiving connections and application of the primary server because the standby server will work as primary server, presumably after it fell over. If you're using a wall archive, its size can be minimized using the archive cleanup command parameter to remove files that are no longer required by the standby server. The PG archive cleanup utility is designed specifically to be used with archive cleanup command and typical single action standby configurations. Note, however, that if you're using the archive for backup purposes, you need to retain files needed to recover from at least the latest base backup, even if they're nowhere needed by the standby. Okay, so that's kind of the end of my set of slides. Remember that all of Viscosity webinar recordings, conference sessions, and slide decks will be posted for OraPub for free and paid members. Funny little picture of the Postgres elephant dancing, and then I'm going to go ahead and show you guys my my labs, my lab demonstrations. Let me know if you can't hear this. Turn the volume up as high as I can.
All right, welcome to the first lab in our webinar today over replication. In this lab, I'll be demonstrating how to quickly set up asynchronous physical replication between these two VMs that have pre-staged, Ubuntu 1 and Ubuntu 2. Both these servers already have PostgreSQL version 17 installed, and remote access has already been set up as necessary with the PostgreSQL conf and PGHPA files. Now, what we'll be doing here are making additional modifications to those two configuration files to allow for replication to take place. In addition, I just want to show you real quick, we're only going to be replicating a very small table. I've created it on Ubuntu 1. That is the intended primary. Ubuntu 2 will be the intended standby. You see here, I've inserted into it, and this is just to show you on the Postgres side that PostgreSQL, let's see, hold on. Sorry, on Ubuntu 2, yeah, that they don't have any tables currently created. So you'll notice there's nothing there, whereas there is on Ubuntu 1, right? Okay, so let's get started. First thing we're going to do, yes, let's connect to the intended primary. Okay. Try that again. Okay. Here, change the context of Postgres. Okay, first thing we need to do on the primary is modify PostgreSQL file. Okay. Quick search function. What is the first one? Okay, so largely we're just going to be uncommenting a few things. Let's do this. Insert function. Okay. Go ahead and save that. We'll need here too. So let's just do this for the purposes. Okay, replication. I haven't created this role yet, but I will in a second. The role, and then the IP we're going to make. It's the IP of the secondary, the standby. I'm going to 2. Okay, so that's going to be. Let's see here. 1, 8, 6, 7, 4, 9. Okay, replicate all. Okay, so we gotta go ahead and create that role because I forgot to do that a second ago. So here. Yep. And then and I need to go ahead and make this screen a little larger for everyone. Apologies. Let's do this. Okay, role created. Get out. Now we've got to go ahead and restart this Postgres cluster for these changes to take effect. So click on restart, see if that worked out. Server started. Okay, so close that session. Let's go to the secondary. There are a number of changes you have to make on the secondary. Mainly, we have to remove the PG data directory that's already existing there, recreate it as an empty folder, and assign specific permissions to it and ownership. So, one other thing we need to do is on the primary, create the master replication slot. Okay, we just created it. All right, that makes sense because we restarted it. Okay, so we're on the secondary one now. So let's see, Postgres. In order to make modifications to that PG data directory, you have to stop the PostgreSQL cluster service. And that's exactly what we're going to do. Using the PGCTL utility. Okay, server stops, but make this larger too. Alright, now let's go to Postgres role and go in as root so we can make these modifications as necessary. So we're actually going here. Okay, so we gotta, if you went into main here, this is what the PG directory looks like of the previous PostgreSQL instance. We need to remove that. It's not there anymore, and we make it. That's an empty directory main. Okay, now we need to, because we made it as root, we need to establish that it's owned by Postgres. Okay, and we also need to assign specific permissions. Just like that. Okay, now, let's you know what, let's just, right now, present working directory. Here, Postgres, go back to that. Okay, so I'll change the file level. Okay, so from here, now we're back in the context of Postgres, and we're going to need to go back to to where we just were within the PG data directory. So there's nothing there yet. We're in main. And then from here, we're going to invoke what's called the PG-based backup from the primary server. We're on the secondary server with a very specific set of flags. Let's see here. PostgreSQL image backup. Cool. Okay, so I just want to make sure we're in the right place. Okay, now we did this Postgres. So then we need to go ahead and start this service back up, and asynchronous physical replication should take place now. So we'll see in just a minute. We'll double check it too. Okay. Let's just start it, see what we get. So that's key point here, started streaming wall. Okay, let's do this. Okay. So the first thing we're going to do, let's just insert a new value here. Well, let's give it a minute. So currently, because this is asynchronous, so just keep that in mind. 2, 3, 4. Insert another value. I'm just trying to see. Maybe I'll do a checkpoint in a second. And then maybe we can force a checkpoint here. Think through that. On the primary. Just make sure it's still there. Okay. Now, if you go to the secondary, hit refresh, BP simple, public. Okay, so the table is there now. Let's query it real quick. Okay, you'll see that all the rows are there. Let's just do another one. See how long it takes. Might take it a minute. Nope, it pretty quick. Okay, so that is asynchronous physical replication. Now I'm going to do a quick demonstration of how to convert this from asynchronous replication to synchronous replication. Let's see here. Actually, you know what? Let's go ahead instead. Let's simulate a failure of the primary, and I'll just film the synchronous replication as its own lab. So just real quick, for now, so we're on the secondary. Let's see what happens if I tried to insert a value on the secondary. It shouldn't allow write operations. Okay, can I insert? But then let's just go ahead and, like I said, simulate server 1 going down, so we'll shut it down. Okay. So from here, okay, so that's down. You're going to get some errors, likely, in Ubuntu 2. Yeah, it's going to be something along this lines. Fatal, cannot connect to the primary server, cannot receive data. So what you'll want to do in this situation is promote this secondary to primary. And you can do that pretty easily using the same pgctl utility that we were using earlier. And you'll do it like that. Server promoted is the key point you're going for here. And what you'll notice at this time, I'm on the secondary machine. So if I do a select, okay, I don't know why it's not, in a second, let's refresh. Giving me a hard time here. Checkpoint complete. Just do it in here. I would rather do it in here. Okay. Okay. Insert into. Okay, so you can see that I can actually insert into this table at this point. And there's that 7th value. Okay, so that's just an example of promoting a secondary. Okay, in the second lab, we're going to demonstrate how to quickly build logical replication between these two VMs, Ubuntu 1 and Ubuntu 2. These are the same VM images as previous. They have PostgreSQL 17 on them, and they've already been set up for remote access. Okay, so we're going to start with the primary, the intended primary, making specific changes as necessary. Okay, so the first thing we need to do is alter the Postgres file. Okay, so this time, instead of leaving it the wall level as replica, we're going to change it to logical. Set. Okay, and then also alter this one. And that's it on this. Okay, that's the first one. Oh, that's right. We got to restart it for these changes to take effect. Yeah, so definitely don't forget to restart the PostgreSQL service after making these changes in the post-conference file. Okay. Let's disconnect and reconnect. Okay, cool. Now, let's go ahead and just create a very small table just like previously. Okay. Let's go ahead and make these changes to the secondary or standby server as well, because it would be a standby in this case. It's just the secondary. think that's everything on this one. Okay, same thing. Don't forget to restart this Postgres instance on the second one. All right. Okay. So we've created the table on the primary, have yet to create it on the secondary. And the reason I mention it like that is that, oh, you know what? Let's go ahead and just make sure we put this on the secondary. Okay. Okay. So to create the baseline for logical regression to take place, we actually have to do a PG dump, and we're going to pipe it in, almost like a restore. So it creates the tables that now exist on the secondary, specifically this table right here. So if you were just to refresh this, you'll at least see at this point, well, okay, so the table's there. I don't know why the pgadmin client tool is freezing up on me. So you have the baseline because you've done a PG dump and then essentially a restore. But we don't have replication going yet. If we were to insert rows at the publisher, we wouldn't necessarily see them at the subscriber. So in order to make that happen, we need to do a series of steps here. Let's see. So this is just there are many ways to skin this cat as far as how you create the publication. I'm going to do so for all tables within the BP Simple database. Okay, then when I go to the subscriber, I'm going to create a subscription like such. Okay, so create a replication slot, my sub, that's what you wanted to see. So now the question is, if we input a value here, okay, will we see that value 5 reflected at the subscriber? Previously, when we saw 4 rows, okay, so there you go. The 5th row has made its way through. This is logical replication. Okay, so I hope you guys can hear me now. Those are the 2 labs that I had. I do apologize for the audio quality on the first one. Give you guys an opportunity for additional questions, or if Monica, if someone else wants to speak, that's...
Yeah, so thanks for joining us. We will get this webinar posted online either at NYOUG.org or at Auropub. So just give us a day or so to try to get those posted. And then we'll also get these demos from James. So then maybe we can bump up the audio a little bit too and then repost them for you guys to rewatch. So I think that's it from me, Coleman and Rob. Thank you guys so much. I think we've got some upcoming webinars together that you guys can check out, NYOUG and Viscosity. So make sure you register for those. And otherwise, Coleman, did you want to share a little bit about that Oracle event happening in New York?
Yes, there's a Oracle event coming up. Let me just get the whole thing up. We have one moment. Everybody hang on, please.
If you're local, it'll be great to go out there.
November 6th. Oh, in fact, I'll give you the whole list of things going on. I just get to 1 second. That's
No
got me
worries.
there. Okay, here we go. We've got Oracle at Oracle Cloud VMware Solution Test Drive, November 6th from 12:30. It's going to be at the AMA Conference Center, 1601 Broadway, 6th floor. Just show up there, or if you get our email blast, it is listed on the email blast. And while we're at that part, next week we do have an innovative Q&A interface powered by generative AI. That's October 29th. And next we have November 12th, a smooth and seamless migration of legacy Sybase database to Oracle. So we have a jam-packed sessions coming on through this November 6th and also through the rest of the month, the 29th, and also November 12th. So hope to see everybody there. Thank you, Monica.
Thank you. All right, everyone. I hope you have a great rest of your week. And thanks again to James for presenting to us today. And we look forward to seeing everyone next time. Thanks, everyone.
Thank you.